Hello, everyone. Good afternoon and good evening to one and all. Dear authors and invited guests, welcome to Technical Session 6A. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to this international conference. That is International Congress on Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th edition of this conference is being held in a hybrid mode, and the physical conference was held in London, that is on 20th and 21st February, and the virtual conference is being held that is on by 22nd and 23rd February. I hope you will enjoy this informative session, and in this session, we have 6 presentations, and each presenter would be getting 10 to 12 minutes for their presentation and 2 to 3 minutes for question and answers. On 10 minutes, I'll give a time check. So please take care of the time, as we do not want any delay in the further presentations. And if there is any query, you can drop a message in the chat box to me. And I request the participants to stay connected till the end. And now I would like to introduce to our session chairs, that is Malika Ivanova. Just a minute. She is an associate professor at Technical University of Sofia. Her research areas are machine learning, data analysis, security and privacy, technology-enhanced learning, information systems. Recently, she was involved in the following projects, that is exploration of the applications of statistics and machine learning in electronics, and modeling and research of intelligent educational systems and sensor networks. I welcome you, ma'am, on behalf of the team. And we also have another session chair with us, that is Sachin Gupta. He is a passionate technology enthusiast and educator with teaching and administration experience of over 20 years. He is presently working in MVN University as Dean and Professor in the Department of Computer Science Engineering. And he is an associate life member of CSI and life member of Valier Academic of Mathematical Sciences. He is actively working with several research areas like artificial intelligence and machine learning, cybersecurity, blockchain technology, and social media analytics. I welcome you, sir.
Thank you so much.
Yeah. Ma'am, you would like to give a quick brief about yourself, ma'am? Malika Ivanova.
Yes, hello from Bulgaria. I'm so glad to be here right now with these great colleagues and their topics for research. So I wish success to all of you in your presentation, and I will be happy to collaborate with all of you and to chair this session. Thank you.
All right, so we'll start with the first presentation, that is by Siegfried Rodel. He would be presenting his paper on 5G standalone test bed for craft businesses and small or medium-sized enterprises. Sir, can you hear me?
Hello, I can hear you.
Yes, sir. So you can start sharing your screen.
Yes. One moment. Okay. Can you see my paper?
Yes, sir. I can see your screen, and audio is also clear, so you can start. Yeah, thank you.
Okay, thank you. Then I will start. Okay, also my name is, as mentioned, Siegfried Rödel. I'm research assistant at the Deckendorf Institute of Technology in Germany, and I present our topics, 5G standalone testbed for craft businesses and small or medium-sized enterprises. So I work together with my colleagues František Kopčík, Markus Petrans, Lorena Pöschl, Stefan Kunze, and myself. Just a quick overview for orientation. Our institute is located in Bavaria, near Munich, you know, Oktoberfest. And my technology camp, where I'm working with my colleagues, is located in Freyung. That's a few kilometers besides Deckendorf, and near the border of Czech Republic and Austria. About the topic itself, a short introduction regarding 5G. Also 5G is an important factor for the digitalization. So for topics like Industry 4.0, big data, industrial IT security, embedded systems, communication software, digital living, e-village, and so on. And also 5G is also one of the important communication standards like Wi-Fi 6E for the less critical networks, or besides currently used 4G mobile technology, like also called LTE. And 5G is in our paper important topic for the, like mentioned, small and medium-sized enterprises to explore the potentials for new business models or the 5G integration in products or establishing its own 5G networks for medium-sized companies to have a more robust or just a better network compared to Wi-Fi networks. But this also has all its challenges. And we are currently in a project in cooperation with the Chamber of Crafts in Nether in Lower Bavaria. Together we are working to increase the knowledge of 5G for the small and medium-sized enterprises, but also especially for craftsmanship. So for workers like electricians or carpenters. We're also organizing events and workshops to spread information about 5G and also creating learning materials. About 5G, a quick overview also. Also 5G is the 5th generation of mobile networks. It's an evolution of the current mostly used 4th generation of mobile networks. It's based off the 3GPP standard release 15. Also the 3rd generation of partnership project. And this is just as a quick overview. Also 5G is not one big block it's coming now after 4G. It's a continuous development within the standardization premium. 4G, for example, is the 3GPP release 8 until release 14, and with release 15, we have now the 5G, also the 5th generation. And it's also still continuing to develop and to get new features. 5G itself is able to work within frequency range 1, also everything below 6 gigahertz, like 800 megahertz, 1.2 gigahertz, and so on. And also the frequency range 2, that's also called millimeter wave. So more or less everything above 24 gigahertz for the short range communication, but with much higher bandwidth, because there's more frequency available, also more spectrum available. And also with 5G, we have the 3 focus points like EMBB, also the enhanced mobile broadband, what could be also called the currently used 4G network, also everything regarded with throughput, also that needs throughput and mobility. So what we have now with our smartphones. But with 5G, there are 2 new focus points like ultra reliable low latency. So everything real-time related and with more robust requirements. And also the massive machine type communications, which is just a massive increase in devices that are connected to our 5G to our network. So it's mostly for if you have a lot of sensors that needs to be connected. The current status of 5G, with release 17 of the standard is out. With it come some features like the range extension up to 71 gigahertz, which is already extremely high. So we enter a bit area of frequency magic, you could say. And also IoT over non-terrestrial networks, so satellite communications. On the hardware side, we have now getting release 16 compatible hardware that can be used, that enables features like ultra-reliable low latency. And just as a reminder, even if the standard 17 is out, it still needs time until you can get hardware that supports the standard. For example, release 16 did come out 2 years ago, but now we only get hardware that is compatible to the standard. So everything just needs a bit of time. So regarding our test beds that we set up, the goal of our testbed, 5G testbed, was to research 5G systems, to be able to look into the communication within 5G networks, so on the core side, base station side, also UE side. We also wanted to set up some showcases for 5G to show some applications or to show some use cases for 5G networks, and also to be able to give businesses, also companies, a chance to test their business applications and also to make some hardware tests. Regarding the implementation, also our network has a 5G core that is inside one of our servers. Besides this core, we have also the centralized unit. The centralized unit is part of the also called G-Node B. So this is G-Node B itself is like the base station that you have near your antenna systems of a mobile network. But with late releases of 4G and also with 5G, you can separate the base station into the centralized unit, also the could say control plane that is more layer 3, high level communication. And in the DU, the distributed unit, that does the heavy lifting, the low layer communication and the computing. Connected to our DU, we have our PTP switch, a precision time protocol switch. And over the switch, we connected our 2 radio units that each are connected with 10 gigabit fibers. And this radio unit supports the OWAN standard, also called Open WAN, which has the benefit that this is standard, those some holes that are in the 3GPP standard, so that you are able to exchange radio units between different vendors. Until 4G, everything from a vendor was more or less closed hardware. So if you bought hardware from Nokia, you have to stick with Nokia. If you have bought hardware from Ericsson, you have to stick with Ericsson. But with Open WAN, it's becoming more open, transparent, so you can exchange some parts of the network. And also we use for our networks the band N78. That means we use the frequency range from 3.7 gigahertz to 3.8 gigahertz, so 100 megahertz bandwidth, which can be used in Germany for private 5G networks. But you need a license for this. Regarding the applications, like mentioned, there are the 3 focus points, the massive machine type communications. We just want to have a huge number of devices connected to your network. The eMBB, where you could have some application like cloud virtual reality or augmented reality, where you compute the pictures within one server that has for high resolution pictures, and then stream this picture to your device, your VR goggles, for example. And for this, you need high throughput, but also low latency. And like we mentioned before, the ultra reliable low latency, where you have now real time, also which extremely depends on low latency and also extremely depends on high reliability. For example, for emergency systems, that can be implemented this way without the need of wires. And these 3 focus points, what you should also keep in mind is that you can't use these 3 focus, also all these features at once. So you have to decide what is your focus point. But there is some kind of solutions. It's called network slicing, where you can have these kinds of focus points or adjusted networks in parallel. So you have one part of your network or your base station can support functions within the EMB area, or another slice works configure it in an ultra reliable low latency field, and you can connect then your device to the networks that is needed. So regarding the applications that we set up in our camp, we have one mobile robot that
Dear
is.
presenter, you have 2 minutes left.
Okay, yeah, I will finish shortly. We have a mobile robot that is connected to our 5G network. It has a video camera that transmits a video signal with low latency to our computer, where we can also control the robot. The setup shows the benefits in 5G in the field that you have a longer range, because the modem that we use for the robot works with lower receiving signals. So with Wi-Fi, you have convert to a signal level of -80 dBm signal level. With 5G, you can go below to -100 dBm, which is times 100 better than what you can have with Wi-Fi. And also with 5G, we have a demonstrator where you can show that you can put a 5G modem on your control box that you have, also, for example, PLC controllers that you can put at the customer area. And over the 5G modem, you have the control to this modem without using the company's network. And this connection would be good enough to realize any functions that you would need. Also, features like remote assist, where one worker is at the customer side and you can give help for this worker on the field without the need of bothering the customer with his network. Some conclusion and future work. So some conclusion was there's just slow adoption to 5G. So many companies still lacking some knowledge about 5G. If they hear about 5G, they just think about, yeah, it's just a bit better than 4G, a bit better throughput and so on. But there's just more flexibility with 5G and just more possibilities that with 5G that you instead of what you could have with 4G. Also, we are working at the demonstrators that shows the benefits. Like on the right side, we have some simple demonstrator where it shows the latency, where you can feel what it means if you have a bad Wi-Fi network with high latency and high variation of your latency from like 10 milliseconds up to 1 second, and compares this to, for example, 5G network, which has around, for example, 50 milliseconds to 50 milliseconds, and which is would be just much more stable and usable compared to a bad connection. And also, a bit due to the 5G development, as it's mentioned, we currently have release 16 hardware able, which enables network slicing on the one side, also ability on the have these functions that I mentioned in parallel. Millimeter wave is becoming more relevant and better available. And also features like the location service becomes available, where you can locate your device using a 5G network without GPS and stuff like that. Okay, that's so far for my presentation. Thank you, everyone. And now would be time for questions.
Okay, thank you so much for your great presentation. Actually, I'm wondering, do you have any research in the area of security and privacy in the era of 5G?
Mm-hmm. Also, we are not researching also the 5G security itself, because in our view, we would say if you want to have a secure connection, you need additional security layers like VPN tunnels and so on. So also my personal view of the things is, don't trust any network. You need additional security, because you can't be sure that some network can't be compromised. For example, if a SIM card comes out of your hands and one a third party would get hold of the SIM cards, and you have access to a network. So you need an additional security level for your applications.
Thank you so much for your answers. Thank you.
Just a quick question from my side. What is the cost of your test bed?
Our test bed, also for one site, it was around 100,000.
Okay. What if part of it was based on cloud?
You mean the core, or what do you mean?
I'm just asking, what if part of the infra that would be based on cloud, would it actually reduce the cost, or?
Yeah, so not really, because we wanted to research on the hardware, so we wanted to have the hardware in house, so we can place our measurement points, and also we want to reduce the ongoing costs. So if we have everything in house and have also software in house, so we don't have to pay in the long term with for cloud, as we would have for cloud solutions. And also we try to implement at a later point open source software. For example, one student is working on an open source 5G core solution, also not the solution itself, but how we can implement such a solution in our network, so we can switch later on to cost-friendly or low-cost-friendly solutions to have low cost in the long run for our network. Because the hardware itself is mostly standard server hardware, like a Dell server, and just the radio units are currently special hardware. So it could also be exchanged with other radio units because we have Open WAN.
All right, thank you so much. I got it. Your answer actually was giving me more information about your project rather the complete presentation. Thank you so much for that.
Okay, welcome.
Thank you. Thank you for your presentation. Okay,
Okay.
so we have our next presenter, Mohammad Essam Mustafa. He would be presenting his paper on ANN-based modeling and control of a pick and place manipulator. I welcome you, sir. Can you hear me?
Yeah, I can hear you.
Yes, so you can start sharing your screen.
Okay. You can see now?
Yes, I can.
First, hello everyone. My name is Mohammad Hassan Mustafa, master student at FAO Research Inverse, and today I will present paper with title ANN-based modeling and the control of pick and place manipulator. First, table of contents. First, we have our abstract, then introduction, methodology, results, conclusion, because if we have question and answers. In abstract, pick and place robots are used in manufacturing industry. So this paper will focus on one of the most used functionality in the industry. In addition, it will focus on this functionality and how to achieve more precision with the least cost. The robot is used for packaging, picking, placing factory jobs, and inspection. This paper is focusing on the design of linear pick and place robot. The target of this paper is to tackle the design, construction, control, and the analysis of the linear pick and place robot. The main target is to find the best design and the most cost-effective way to develop it. It will be done by comparing several Delta robots design to find which one will be the most economical. Okay. The expected outcome is a pick and place robot with improved precision, in addition to the design being new and straightforward. In this context, work method will be based on designing several designs with simplicity in mind to achieve the required simplicity after the phase come to the analysis phase. The main aim of this phase is to produce the most suitable materials that we can withstand the operational conditions, while being safe enough and most importantly, affordable to do so. Several analyses will be done on varied materials, and based on the results, the material will be picked. The third and final phase before manufacturing is the control of the robot. This phase is critical and it must be done personally to ensure perfect robot control. Second, methodology. In methodology, first we will talk about the Tripton design. The Tripton is a pyramid mechanism constructed of 3 legs, each of which consists of 4 degrees of freedom. So mechanism was connecting from the base to platform. The prismatic joint is ensured at the bottom by 3 joints whose axes are aligned but not orthogonal to the prismatic joint axis. Their 3 legs final joints are attached to the movement from such their axis is orthogonal. The mechanism is the result of aiming at uncovering the kind of parallel transition mechanism. Despite there are many trapton types, the orthogonal trapton is the most important one. The axis of prismatic joint is orthogonal to the another one, and an axis of passive revolute joint on a particular limb is parallel toward the course of the prismatic joint. The platform probability is controlled by actuators through one of the Cartesian planes. Here we will talk about the neural network and we'll define it. First, neural network, also named artificial neural network or simulation neural network, are the foundation of deep learning techniques, and these have been named and built following the human brain to mimic how physical neurons communicate with each one with one another. Node layers in artificial neural networks include three levels. First is input, then hidden and contains one layer or more, and the last one is out. Each node seems to have a connected node, a limit, and a weight associated with it. When a node output exceeds a certain limit, it is in active mode and starts sending data to the network next level, or else no data is transmitted in a subsequent level of the network. To adapt and improve over time, neural networks require training data. Nevertheless, when this training learning algorithms have been fine-tuned to improve accuracy, they have been used to create effective tools which enables us to organize and combine inputs more quickly than if we did it manually. This robot's successful operation involves detecting an object position via computer vision. Then the movement of the three motors should be calculated accordingly and sent to the microcontroller. To achieve this, there are two ways. First, inverse kinematics or neural network. But in our paper, we choose a neural network to reduce the complexity. In this case, a 612-3 multi-layer feed-forward neural network was used. It consists of three neurons input layers, each for the position along the three axes X, Y, and Z, and an error variable of each axis. The second layer is the hidden layer, which consists of 12 neurons with segment activation function. The third layer is the output layer consisting of three neurons. Each neuron outputs the required rotating for each motor. Here we is the table for the training ANN artificial neural network. To train the ANN, a dataset was collected. This dataset records each one as the complete operation, starting moving from home to the beacon and finally to return to the home concerning the target object location. So this table show the data we collected. Okay. Methodology. First, we will talk about the control methodology. We decided to divide the working space into 4 similar regions in the shape of a square to give a position axis X and Y for the boundary of each. According to the axis for each square edge, the MATLAB code is appended to detect whether the object we need to pick is inside one of those squares in the figure. If the object is detected to be out of all squares, the arm will not move as safely and avoid arm break. However, if the object is inside one of the picking place green squares, the code will automatically calculate in which region the object is. The code will organize in which square the object is and automatically send it to the Arduino specific LX and LY, which is the distance the motor should move the card on each axis X and Y. Therefore, the end effector should pick the object and then place in the placing destination the red square by giving specific LX and LY as well. Finally, return to the home position, waiting to detect another object and restart the whole process again. In the concept of operation, detection and feedback are constructed by fixing a camera on the robot at a place where working space is entirely inside the region of view. The camera is programmed using MATLAB software to detect 3 associated colors RGB and a frame for each to give a specific axis and location. So the end effector green position concerning the object we need to pick and place, red given as shown in the figure. Vision system construction. First, we fix the wood stand at the top motor housing of the x-axis. After that, we embed the camera to the wood stand while directing the lens perpendicular to the working space. We install the external camera into MATLAB after connecting the USB to the laptop. Finally, we run the code that will be discussed later, okay, and it confirms that the end effector and the object are detected to inside the boundary box with axis X and Y, as shown in the figure. The result, this result is made on analysis 19.2. Okay, we have three types of analysis. First, rigid dynamics analysis. Second, static structure analysis. Third, model analysis. Okay, in rigid dynamics analysis, this section focuses on the robot velocity and acceleration, and shows the flux translation of the rotation of the joint. The total deformation analysis shows the deformation of the robot, and the material we use are aluminum, chrome, and polyamide. Second is static structure analysis. This section focuses on the stresses on the robot and the total deformation for the robot. Second, we define the fixed support for the robot and add a force to test the material we choose. The force is 50 Newton at the end effector to calculate the weight we can carry, and added 3 joints with displacement of 20 to show the end effector can carry the weight when it's moved. The final analysis is the model analysis section, focus on the effect of vibration on the robot and shows the total formation at different frequencies. Here, first graph is the workspace of the robot. Okay, after we collect the data, we need to obtain our workspace. So we use MATLAB to obtain this graph. Second is a scatter plot, 3D scatter plot for the end position of the effector. Okay, here's the result. Is the final product after manufacturing. Conclusion. The target of this paper is to introduce the design and implementation of an accurate pick and place robot that is fast for the job to be done. Eventually, several stress analyses were done, and based on the result, varied metals were assigned for each part depending on the working environment. The robot was composed of 3 materials: aluminum, polyamide, and metal. To control the robot in the next phase, we will use computer vision for object detection. Okay. For sensory data of the end effectors, we have IMU sensor attached to measure the acceleration and data for controlling purpose. Thanks for listening. Any question?
Thank you so much for your presentation. I would like to ask you about how did you construct the artificial neural networks, and to give much details about parameters.
Okay, when we try to obtain the parameters, we use potentiometer and try to collect the data manually. Okay, so we try to we use a potentiometer at the control and measure the data like LX, LY, LZ from the Arduino. Okay, so this data we input it manually. So we collect about 100 data sets like that. 1,000, but if we need to make it more accurate, we can collect more data. But it's a sample for graduation project, so we see that this type of data can be fed or suitable for that.
Okay, thank you.
Thank you.
What did you exactly optimize, may I ask?
Okay, what is the question?
What did you optimize? I mean, what was your target eventually?
What is target? Okay, when we search for the robot, we find 2 kinds of robots, serial or parallel. So we see delta robots, but we need to make it more improved. Okay, we improve it that the Trepton can move very fast. Okay, and we carry with more weight. Okay, and the important thing is we make it economical. The main target for us is how to reduce the cost and make it more efficient.
How much did you change the efficiency of what you started with? What was your, how much improvement did you bring into the process when you started with that after the ANN was applied?
Okay, in the ANN, we say about the ANN. Please, can you repeat the question again?
You went out to optimize the parameter. What was the parameter results, or what was the accuracy that you received after ANN was applied?
Okay, the accuracy that when we try to run the robot, if we put an object in the workspace, it will detect it in a fast way. So, but in our feature work, we will try to improve the workspace because from the disadvantage of Trepton, okay, is workspace is small. because we have three linear actuators connected at one end effector. So if the end effector is moved with large distance, it will lead to break of the end effector. Okay, so if we try to make neural network more accurate, so we need to collect more data set. If we need to collect more data for result. Is that good?
All right, thank you.
Thank you.
Thank you, Mohammed. Thank you for your presentation. We'll move on further. We have our next presenter, Inara Opmene. She would be presenting her paper on cryptography in Latvia, academic background meets political objectives. Yeah, so you can share your screen, Inara.
Yes, I'm trying. Do you see?
Yeah, I see your screen.
Okay. Thanks. Dear ladies and gentlemen, dear colleagues, thanks for possibility to present our paper at the 8th International Congress on Information and Communication Technology, now in London. The paper title is Cryptography in Latvia, Academic Background Meets Political Objectives. And my name is Inara Opmene. This work was supported from the project application of quantum cryptography devices and software solutions in computational infrastructure framework in Latvia. And the content of our article is shown at the next slide. And the main attention in the article is devoted to cryptography ecosystem concept, cryptography digital ecosystem deployment framework, and practical tasks, topics for implementation quantum cryptography ecosystem in Latvia. Research was done at the Institute of Mathematics and Computer Science of University of Latvia. Latvia is a small country near Baltic Sea. Our country is located close to Finland, Sweden, Poland, and Russia also. And I am giving some statistical data about our institute. Our institute is founded by Latvia University, the biggest university in Latvia, and institutes operate separately as project-financed institution. Total number of employees at the institute is near 200, and from that, 84 are researchers, others are engineers, technical and administrative staff. At the institute, research performs research projects in mathematics and computer science in different subfields, nationally financed, and also we actively collaborate with researchers from other countries, mainly from European countries, but we have contracts with companies from United States of America also. Besides fundamental research project, Institute is active in innovation projects and applied research. And especially, I would like to stress collaboration with industry also. And now about our paper. If we think why cryptography and quantum cryptography is important, first of all, we should think why cybersecurity is important. Information plays a decisive and comprehensive role in our society. We need to obtain, transmit, and process information, but at the same time, we need to deny and hide access to information also. Therefore, those are extremely growing: public digital information processing, restricted digital information processing, personal data processing in digital sources. And we should use cryptography massively. Quantum computers will crack the encryption we use. Let's see what we should experience: apocalypse, collapse, threat of essential risks to classical computer encryption protocols. The National Institute of Standardization and Technology says that in a matter of 20 years, our current cryptography systems will be outdated and easily cracked by quantum computers. Therefore, top priority of European Union is quantum key distribution networks and post-quantum cryptography solutions. We look at cryptography as a central technological solution for ICT security, and therefore we developed cryptography digital ecosystem concept and present this concept at the 12th International Conference on Electronics, Communication and Networks in November 2022. And you can see publication during this conference. Cryptography digital ecosystem community cooperation partners are bound together by purposeful action, ensuring a high level of cybersecurity in the environment, introduction of safe cryptography tool in the economy, and intensified replacement of classical cryptography solutions with post-quantum cryptography secure tools. We distinguish 3 layers at the concept: operational objectives layer, cybersecurity, cryptography, community and cooperation partners, research institutions, industry, cryptography use case, certification and accreditation, standardization institutions, university education programs, technology producers, ecosystem deployment, orchestration, and attracting ecosystem partners layer. Cryptography digital ecosystem is characterized by complexity, self-organization, emergence, and co-evolution adoption. Cryptography digital ecosystem deployment model rationale. The practical possibility of cryptography digital ecosystem deployment identify geographic area, Latvia, EU member state, adequate level of knowledge in the cryptography field, and available financing. We define the digital ecosystem vertically as ecosystem status, in our case, EU level and national level, and also horizontally, defining the boundaries that include technology, cryptography, in our case, ICT security and cryptography as practical instrument for security needs. We will base the compliance model of digital ecosystem of cryptography on the following features. Cryptography is widely used technology. With the growing importance of cybersecurity, the widespread use of cryptography in technological platforms and security solutions is predicted. There are several arguments to include cryptography in general purpose technology line. Compliance of the cryptography solutions with standards, and migration of cryptographic solutions to post-quantum cryptography. We have developed digital cryptography ecosystem deployment manual, and main issues about in this manual are: cryptography covers an important and very broad spectrum of issues and tasks. Cryptography digital ecosystem deployment must cover this wide range of tasks. To describe the existing situation in Latvia, we developed the manual for cryptography digital ecosystem deployment. And our manual is as point of view, which we should mention user point of view, industry point of view, and also technology point of view. In the manual, initial recommendations and publication recommendations are taken into account, but the content presentation style is more general. Mainly, presentation style is changed from landscape to point of view and state of art. And now, practical project, what we do in Latvia for ecosystem implementation in our country. We have 2 research projects in realization. First of all is application of quantum cryptography devices and software solutions in computational infrastructure framework in Latvia. It is more theoretical and it is devoted to any cryptography solutions. And another one is ICICT National Backbone Deployment Project.
Dear presenter, you have 2 minutes left.
Yes, it is almost the last slide.
Okay.
And it is start only from the beginning of this year. And we are in preparation phase for a project proposal for EU ICICT project on next generation cloud infrastructure and services. And you can see in our in picture in map how many countries participate in these ICICT projects. And next slide. Something wrong with presentation with last slides, that summary and conclusions is that the authors promoted the national cryptography digital ecosystem deployment concept in the view of the authors. This corresponds to depth on ICICT national backbone and international connectivity of these backbones. An example of national ecosystem readiness concept is developed, and proposed a cryptography digital ecosystem deployment concept that includes analysis of networking protocols, ICICT network, and ICICT in OSI layer protocols. Thank you for your attention.
Thank you so much for your great presentation. It's a new area for research about quantum computing and quantum cryptography and security. As we see, you have started project international in this area, and I'm just wondering in Latvia, how do have intention to implement and how far of this moment you plan to implement cryptography, quantum cryptography in different areas?
Mm-hmm. The first stage where we would like to test our technology is for our defense needs, and it is closed network for defense needs. But we also are going and planning to test in bank sector and in health also as test bed for next stage. And we have appropriate technology and equipment since 2019. And we work for our first project and test in real network in our mobile phone network and also in government network also. And we tested in fiber network with length 33 kilometers, and for first stage it is in city, not in rural area.
Thank you.
Thank you for your question.
Inara, just one question. We are still in the nascent quantum era. I mean, there is not much quantum computation power going around. How are we testing for post-quantum cryptography, which would be very extensively requiring quantum?
I would like to stress that the quantum computing and quantum network, it is quite different because we are working in quantum network area, and it did not include quantum computers. We have equipment for encrypting this network, and it is realized for special lines. For example, we communicate with Swiss in they also tested such network, and yes, we crypt this with this technology only in separate lines. For example, for this defense needs and for bank, it is very important to be very secure network.
Okay, I guess I'll have to read much more of your work to understand. Thank you so much.
Thank you.
Thank you, Nara. We'll move further. We have our next presenter, Irina.
Yes. So hello, everybody. Excuse me for my voice a little bit. So, and thank you so much for joining us. And today we will present the topic based on our paper, how predictive software engineering addresses issues in custom software development and how to boost efficiency and productivity. So the predictive software engineering framework was developed by our CEO and President Boris Kontsevoi. It is widely and worldwide supported by engineering community and our team. And today you have a unique chance to speak and to ask questions to our CTO, Alexey Velesnitsky. He has more than 70 years of experience and will cover more in detail the topic.
Hello, thank you again so much for joining us today. Rina, thank you for passing me the ball. And today we will cover, as already said, what is predictive software engineering, how it was developed inside the ICICT. And basically it's a framework and methodology that was initiated by the founder of the ICICT company, Boris Kontsevoi. And the main reason it was designed to eliminate or at least minimize the unpredictability of software development. So the basement for that predictive engineering framework was that the company had already like 28 plus years of successful software development. We delivered many projects in a reliable and systematic approach. We know how to transform requirements into working business solutions. And based on this basement, there was an idea to create predictive software engineering, and it consists of 7 principles, 7 sections. The first one is a meaning customer pair, second, transparent end control, proven productivity next, efficient distributed teams. The predictive software engineering itself is a superset of discipline agile delivery process. That is one of the standards of the market. It consists of measurable quality management and technical debt reduction, in-house built platform Tetra.
Sorry for the interruption, Alexander. I think the co-authors of this paper are Boris, Sergey, and Irina, right?
And me. And
What's
me
your
too.
name?
Alex Velesnitsky, actually.
Okay, but you have not given your name in the authors list because it is Boris.
If you go back a little bit, I mean, actually, if you see this, my screen, actually.
Because only the authors are allowed to give the presentation, not the others. Maybe to the profile, I have just received the 3 names. I don't have your name in the list.
I'm sorry, but we send it, and unfortunately, you hear my voice, and that's why our CTO is together with us, and Alexei is one of the authors. We
Okay.
we applied this information, and so it's a little bit, unrespectable to do
All
like
right,
this,
then
because we
okay.
provided
I'll have to
all the
talk to my
information.
team. Maybe there would be some problem with the certificate issue. So that is the reason I just told you. All right, no problem. Continue. I'll just have a word with my team and let you know.
I think
Yeah,
certification could be
sorry with
resolved
that.
by.
Yeah, actually, the reason was that I will be leading the Q&A session, but as you can hear, the Irina hardly speaking today. So I'm as I'm using the PSE at the moment daily, so I decided to help her with that presentation. If that won't be a problem, let's continue. So let's get back to the PSE itself, and the first principle is basically the meaningful customer care. And we actually know that in terms of software development and in terms of outsourcing software development, the customer is usually put first in any type of organization. So it's very important not to only track how we deal with the clients, but make them sort of happy and create even better relationship. So internally, we have designed some 8 strategies inside this concept that it's better to have a customer portal with the self-service tools. We actually had based on in a conference for that too. There must be some sort of onboarding process for a customer. We have to be transparent and have to have the transparent governance model. For any customer escalation, there must be developed an efficient plan. Usually it starts from the project manager inside the concrete project. The early problem discovery should be prioritized. The customer complaints should be analyzed. And the more important, the customer expectations must be managed and set with realistic boundaries. And I'm talking about the estimates, the product milestones, and something else. So let's move to the next one. The second concept is transparent end-to-end control. And basically, as we may know, the transparency and it can be hard to achieve it in terms of engineering level, because it's always a challenge how to properly measure the productivity of the distributed teams. So in terms of building trust and have to transparent end-to-end control, you must build trust with the external stakeholders, and this is called external transparency. We usually use like agile project management, including the Scrum or Kanban in our products. Basically, you need to regularly discuss governance across the team. The workload management and time tracking software, such as Jira, for example, must be on every project working on in the company. There must be status reports in the projects. So basically, you have to have internal status reports and something shareable to the clients. The on-site visits should be planned, and they must be correlated with the major events. For example, with a project launch or major deliveries, or moving project from the on live to support phase, for example. Talking about internal transparency, this is something that should happen inside on a project, actually. So we're talking about the activities related with the project manager check-ins, the department head meetings with the project members, and the involvement of the talent management team inside the control of these teams. The third concept is proven productivity. This is what I was talking about, how to properly measure the software engineers. Defining and measuring the productivity of software engineers is pretty hard, actually. But there are some tricks that you can use it. And basically, we're using the quality and technical debt reduction system developed in-house. And this tool will be covered shortly. But also, we may say that it's important to focus at least on 10 KPIs to measure velocity. It's basically planned versus actual hours spent on a product development. Static code analysis for the entire project. Static code analysis for individual developers. There is a popular metric like bugs per line of code. for example, 1 bug per 1,000 lines, bugs per feature, and some sort of issues like security issues and checks for that. To some sort of proof productivity and to measure productivity with KPI, there must be at least 2 code reviews for different developers, the document code reviews from multiple perspectives, also from the stakeholder, and the code itself inside the project must be reviewed incrementally, less than 500 lines at a time. Moving to the next one. The whole concept of the PSE is based on that we provide an efficient distributed teams. And by saying that, we mean that actually the clear roles and responsibilities will be defined in the team. So the team will consist not more than 1 project manager, not more than 1 business analyst. It's not effective to have, for standard case actually, to have many analysts in the team. Basically, there will be couple of senior engineers, middle engineers, the structure will be pretty narrow. And the whole team, using that distributed team means that we kind of remote ready, and the customers who are using that team, they basically using can assemble a global workforce for their distributed team. So the cost savings, the time effectiveness, and the talent pool diversification, because you can hire from anywhere, is unmatched, actually. Itself, when we say that the PSE is organization-based framework, it's actually driven behind the scenes by discipline agile delivery process, which is pretty standard. I suppose you're familiar with it. It contains 3 phases, with the inception phase, when you actually have to define the project vision, the vision of what the requirements are, meeting with the stakeholders should be organized. The construction phase, where actually the building project and the software development happen. When the deployments are set, when continuous integration tools, continuous delivery tools are actually built up in the system, and transition. It's actually moving project live. Deploy phase, basically it's pretty standard. Inside the company, we will have projects working on a Scrum, Kanban, or any other methodology, but basically they are all subset of discipline agile delivery process. Going to the 6th component, and we're talking about here how to.
You have 2 minutes.
Okay, thank you. How to measure the quality and the technical debt reduction. So basically, it's very important thing to measure the quality of the code, because the developers and testers will receive objective assessment of their work. And basically, you can say how the system is relevant for investors, for the customers, with the help of the result, because you can see is there many bugs or there are many problems in the code base. Let's go to the next one. And last concept is sound human development. So this is a proper name how treat the people, engineers, and the people in the team as humans. So basically, the discipline agile delivery by itself, the PSE, it's a human-oriented framework. For example, in a company, every single engineer, the senior level, has individual learning path. That means that the training and certification of employees are performed on a daily manner, actually, basically. So you have to continuously improve. When we say that we have a special human resources department that treats our engineers, that works with them, and they promote them to learn something new. Actual things that help adopting PSE, that all these components designed to cover specific software development risks. For example, not defined scope can be tracked, as I said, with a transparent control component. Faulty estimates, discipline agile delivery come into place, and using that, you basically can define the new scope or realize what is going on in the system. If you need the more skilled developers, basically the sound human development tries to mitigate the risk, because the developers in the company and in the framework PSE, I have to learn and have to make certificates in their area. For example, if there is a risk for resource shortage, the distributed team may help with that, because you probably can hire additional team if the capacity of the current team is not enough for the upcoming work. PC basically is stated and have a concrete concept with, as I mentioned, but it's evolving structure. We constantly invite other development companies to join us and to continue work on that. For now, that's all from my presentation. Please do not hesitate to ask your questions.
I just would like to add that predictive software engineering. So we developed this article in co-authorship, and Alexei is one of the major author of the framework, and he is implementing it on daily basis. But also it's worldwide engineering network practice that people are sharing with us worldwide. That's why we are promoting this community and welcoming to join us in this framework development and sharing best practices. And thank you. Please, could you ask our questions?
I have a question to Alexei.
Interesting presentation. So I have one question about predictive analytics. Can you give more information about how and where you plan to embed such predictive tools in your software?
Basically, when I'm saying, thank you for that question, first of all. When I'm saying the predictive software engineering is the framework that tries to mitigate the risk and make deliverable increments on time. That doesn't mean that you are bounded to specific tools during your software development. Actually, what I'm trying to say, to be predictive, you have to plan by using the tracking tools, have regular meetings, component number 2, constantly analyze and improve your team, and on a daily matter, measure the productivity of a team by using the code reviews, standards, how many templates used, for example, how many bugs per feature implemented, and according to that statistics. This is usually done by a project manager as such tools as Jira, GitLab, GitHub, or Quiz Control, who these tools basically perform deployment of the code, and the team has all the statistics, and the manager or team lead has to analyze that. In that way, it can predict if there will be a successful release on a planet milestone or not, actually. So in terms of predictability, we're talking about Power BI graphic with the all release timeline and the successful or not the probability of next release.
Okay, thank you so much. If you have any other questions, now is the time.
I have just one question. You said that in your KPIs for productivity, you are using bugs per feature. I understand that perfectly fine. But when you speak about bugs in the lines of code, do you think lines of code is still a relevant parameter when the languages are actually evolving to Python, where a single line of code actually contains a lot of content?
Perfect question. When I'm saying this is like a 10 standard KPIs, I'm not saying like that all of them are mandatory, actually. But what I'm trying to say, there are languages. For example, not all our projects in the company have the same technology stack, if you understand. Some written on the TypeScript, some written on the Java and C#. And for the backend type of languages, I mean when there is a concrete backend layer with the API, and for example, Java.NET code. This is, I'm not the big fan of this metric, but you can say, well, we can say, hey, it's not the bug per 1,000 lines of code, probably bug per 1,000 lines of code inside the specific folder of the only C# code. So if that makes sense for you. So basically, I'm not saying we have measure every single template or boilerplate code, generated code, not by human, but only that the team was actually the core, for example, of the product. If you, for example, processing the video or just processing the data between the two separate databases, it's a crucial part. This metric may help. But this is not the only one. This is not the mandatory for all projects. For example, if you design in the UI layer on the TypeScript using the Angular or, for example, React.js, it's not mandatory to have such metrics for that type of product.
Yeah, that's insightful. Thank you so much.
Thank you so much.
Thank you. Thank you for the presentation.
Mm.
We'll move further.
Okay, I have one more question. So, what triggers the creation of the framework? So, and how the general idea came up?
Well, the general idea was, I mean, if you see it on the market, you will see that there are methodologies that are kind of good on a project layer, right? You can have a project based on a, I mean, in terms of project management based on a Kanban, and you'll be okay. So you have a team, you have a desk with the in progress, finished, and to do. I'm just giving a simple example, and that would be enough for you. But in terms of how to deal with the many projects inside the one organization, and in terms of dealing with the clients, I believe there was some sort of gap. There are like competitors like Scaled Agile and Scrum, but in our case, since we are human-centric, the discipline Agile delivery and these 6 components connected with them help us to deal with these risks on a company level, not on a project level. If that answers your question.
Oh, thank you.
Thank you. So we have our next presenter, Kuldeep Singh, who would be presenting his paper on stirring data arbitration on facial speech features for fusion-based emotion recognition framework. I welcome you here, sir. You can start sharing your screen.
Okay, just give me. I have to quit it.
Okay, he is not here. All right. Maybe he has some network issue. Milind, are you ready? Please start sharing your screen.
Yes, thank you.
So you would be presenting on yet another parallelism within the hobby time training. Yes, sir, you can start your screen.
Thank you very much. Dear colleagues, thank you for the possibility to share with you some moments of part of my educational work. It's about concept of hobby time training. The hobby time training concept is part of the developer's point of view learning approach, and shortly it's described as perceive the very solution to the problem as a game. That is, the decision-making process itself becomes a game. The hobby time training assumes solving of small, apparently simple problems which encapsulate a deeply hidden potential that could be found out only during the problem solving by the students. The problem decision is made in the student's free time at his discretion. More details are described in reference 11. In the area of computer architecture, when it's viewed as the high-level language interface with the raw machine, the bitwise algorithms are a good choice of problem set. Bitwise algorithms suppose usage of special techniques as word-level parallelism, unrolling loops, and branch elimination. The scope of bitwise algorithms, of course, is very broad, as here are some illustration of the hidden deep inner content of that problems. in the context of hobby time training, we're going to focus on the computing of bit set problem, or namely the population count problem. The problem is apparently simple. By definition, it's to count the number of bits set in a byte, word, double word, etc. The solution should be encapsulated in a function with appropriate prototype. Here is presented the naive solution, which seemed to be obvious one. It is compact, really, and it's universal, but it suffers from several drawbacks. The first one is that performance is of order of n. The second one is that its uses short base block, and that blocks the instruction reordering of superscalar architectures. And at third, control stalls will appear because of the branch instruction. And while the first drawback is obvious, the other two are related to the instruction level parallelism, and of course require knowledge of the modern pipeline superscalar computer architectures. If we look to the translated version of the naive algorithm, assembly version translated, we will calculate the worst cases we have here. There are two main levels of parallelism, actually: local hidden parallelism or instruction level parallelism, and global structural parallelism. But there is yet another level of parallelism, the so-called word level parallelism. It's special kind of data level parallelism on units as bytes, words, double words, etc. The word level parallelism is a direct consequence of parallel internal structure, the arithmetical logical unit. As already noted, bitwise operations, and among them the population count problem, contain hidden creative potential. One manifestation of it is the opportunity to use the word level parallelism. To improve our current solution, we will need two elaborations: to find the alternative way of counting bit set, and secondly, to find a base unit to apply this alternative at. As a base unit, we tried nibble, the 4-bit sequence, and as alternative way of counting bit set in nibble, we use the equation-free operation. The operations which are included in these equations actually are of two types. We have free shifts and free subtractions, because the for function is not explicit. Firstly, we implement the basic idea from equation 3 over the nibble. And here actually we have not any word level parallelism. Secondly, we are working with a byte, and this trigger the first level of word level parallelism, and the operations of the equation 3 applied for the two nibbles in parallel. There is one additional step of summing the two sums as commented here in the code. Next, we are working with word, and here we open another level of word level parallelism. Equation 3 is applied to 4 nibbles in parallel. The summing of the 4 partial results is in 2 steps. At the first two pairs, 4-bit sums are added up in parallel. Then a pair of 8-bit sums is added up to form the final result. Working with a double word, we reach another level of word level parallelism. And here equation 3 is applied to 8 nibbles in parallel. The summing of the 8 partial results is in 3-step in this case, as you could see from the commented code here presented. As could be expected, of course, the hardware supported algorithm of the population count shows a drastic reduction of the complexity to only 4 machine instructions with comparison to nearly 200 instructions of the naive algorithm. Finally, here is presented the complexity estimation of 3 classes of algorithms presented. At the bottom, one could see the naive algorithm. At the middle, the results for word level parallelism, and above the hardware supported version, which is, of course, beyond the competition. As a conclusion, we could say the next. From one side, you cannot be innovative in the big if you never even try to be innovative in the small. And another conclusion is that we here encounter the phenomenon of what is considered as obvious solution eventually it turns out to be the most inappropriate one. Here is the link to author's GitHub repository with the details of the solutions. Solution 15 references are listed. Thank you very much for your attention.
Thank you so much for your presentation. I do not have questions, but maybe Professor Gupta have some questions. So please.
Milan, thank you for the presentation. It was actually very interesting to revisit the concepts of how processors work and how parallelism works. Is there a way to understand that if your research was supposed to be commercialized, I mean, would it be actually working with the presumption that the word lengths in CPU are usually constant and they are variable only in a limited number of cases? Or is it? Yeah.
The main goal we set before us here is to show to the students that the decisions they mean are obvious mainly are the bet one decisions. And when they teach different level of parallelism, low level or high level parallelism, they forget that there is another hidden level of such parallelism, which is because of parallel structure of arithmetical logical unit. That's here.
Okay, all right. Thank you so much.
Thank you.
Thank you. So we have our next presenter, Kuldeep Singh.
Yeah. Yeah, I hope it will be visible now.
Yes, I can see your screen. Yeah.
Okay. So good afternoon, everyone. My name is Kuldeep, and I would like to present my research work, which is a staining data arbitration on the facial speech features for the fusion-based emotion recognition framework. Yeah, and this is the presentation outline. We're going through the introduction and what is the main problem description, and what is our proposed approach, and what is the performance analysis and conclusion and the future work. So as we are humans, and how we can communicate with each other with the help of verbal and the non-verbal communication. And just by looking at a face of each other, we can simply say that whether the person is happy, sad, or whatever he is feeling. But sometimes what happens, because suppose sometimes the front person may be faking his or her emotions. So at that time, the other mode of communication may be helpful. So suppose like some person is making the happy face, but inside he is not happy, or he is maybe faking his emotions. So at that time, the other modalities like speech may contain some useful information, or the other modalities like the psychological signals also contain some useful information for that. So in our research work, what we have considered, we have tried to recognize the seven emotions. At least there are 27 emotions are there, but we have narrowed down our research on the basis of these 7 emotions. And how we have narrowed down it based on the computing power and the availability of the dataset and the hardware. So what is the main problem description which we are dealing with? Firstly, the existing works, we can say that they are unable to deal with the multimodal data. There are very few researches for that, and in some research work, it has also been mentioned that the increasing the number of layers in the deep learning model will also increase the accuracy of the model. And what is the correct choice of the model for our use case? And at last, the main motive is to create a better model for the existing emotion recognition for the modalities which has been used. Basically, we have used the face and the speech modalities for our work, and at last we have merged them to create a super model, or we can say a multi-model approach. So what are our proposed approaches? So in this work, basically we have proposed the 2 approaches. So in the first approach, what we have done, we have basically created a facial model which we simply recognize our facial emotions. And the second one, we have created the speech model. We simply recognize our speech. So at last, that is what we have done. And we have the 2 models, right? We have a one facial model and we have one speech model. And so at last, we have tried to merge these 2 models into a one model so that we can benefit with the modalities of these 2 models. Yeah. So in the first one, what we have done, as we know, there is the open library for it. There is a Keras and a TensorFlow in which there are the openly available models for that. So what we have actually done, this is our first model for the facial emotion recognition. In this, what we have done, we have taken the base model as a MobileNet V2, and we remove the layers, of this particular model. And we added our own layers to this particular model. As you can see, these are our own layers which has been added by us. So this first one is a dense layer. Dense layer is basically used to accumulate all the data which has been in this particular model. As we can see, the MobileNet V2 has its own learning. Simply, we have used the transfer learning technique for this. And in this, what we have done, we have simply accumulated all the learning of this particular model, and we have used our own layers to bypass, or we can say to accumulate all the learning from the images which has been fed to this particular network. Yeah. So these are the layers which has been added to this model. But the layering effect is not somewhat individually effective. So what we have done next, we have simply augmented the dataset. Here we have used the FVI 2013 dataset, which is the facial emotion recognition dataset. And here we can see this is the actual dataset which has been openly available. And we have used these parameters to simply data augmented this dataset. And we have tried to normalize, or we can say uniformly distribute these values. As we can see in the original dataset, there are very low images for the disgust emotions. So after the data augmentation parameter, the images may be somewhat uniformly distributed. Yeah. So what next we have done? So these are the models which has been used by us from the TensorFlow library, and these are the individual accuracies for this model. This is a 6459 and 53, and these has been compared with the existing works. These are the CNN, AlexNet, and Net. But these individual accuracies are very less. As we can see, there is 64.2, as the human accuracy is 65 to 65%. Yeah, so this is a very low. So what we have done, so we have tried to incorporate this model with the another approach or the another modality, we can say. So in the second approach, what we have done, we have created the another model, which is a speech model, right? With speech model, so what it will take, it will take the speech sample and it will give us the output for the speech, that is whether the person out of the 7 emotions which has been considered earlier. So in this, we have used the 3 data set, that is the RAVDES, SAVI and TEST, and we have used the RAVDES as a baseline because these 3 data sets are not equal, as we can say. So simply we have converted this data set, that is SAVI and TEST, to the RAVDES line, simply taking it as a baseline model. So this is a speech model which has been created. These are multiple, like the convolution layer and the activation and the dropout layers. So after that, this model has been compared with the existing work of this speech emotion recognition. This is Abdul Malik search, and here we can see in this lower plotting graph, here the red one is ours, and the blue one is the Abdul Malik search. And here we can see that there is a significant improvement in our speech model. So at last, so from the previous 2 approaches, we have got our own models. And so this one is a facial model and this one is a speech model. So at last, what we have done, we have used a concatenation layer, or you can say it is a summation layer, which has been added to the model at last, so that it can acquire the powers of these 2 models. So that so at last, what have done, there is a SAVI dataset which has been used, which is basically the correlated dataset which contain the images, and these images which contain videos, and these videos has been converted to images and a speech sample, and this has been individually fed to each of the input values of these 2 models. Like first, speech will be input to the speech model, and the image will be input to the image model, and at last it will give us the output. So these are the individual performance analysis, as we can say. So these are the individual performance analysis of the facial model, as we can as we have seen. This is the individual performance analysis, 61, 64.59 and 50. This is the individual for the facial model, and for the speech, these are the individual accuracy, that is a precision recall and F1 score. And at last, this is the main model, which is a fusion model. After that, the fusion has been done. Here we are used the SAVI data set, which has been used by the Yongli's work, which is a state of art work in this domain. And here we can see that our model is the red one, and the Yongli's work is the blue one. And here we can see that we have a little bit improvement in the happy emotion, as there is a 1.3% of the improvement in the happy. This is happy emotion, and also there is a 1.8% improvement in the disgust emotion, as we can see, and also there is a significant improvement in the surprise emotion, which is 6.4%. And as you can also see that there is a decline in our accuracy for the neutral emotion, and there is also a decline for the fear. So there are some trade-offs.
Presenter, please conclude. You just have 2 minutes.
Okay. Yeah. So at last, these are the overall accuracies, which has been, our accuracy is very 90%, and the existing work has a 91.25%. So our accuracy is quite low with the existing work, but we have a significant improvement in the individual emotions. So yes, this is the main conclusion, that we have created a model which has been a significant improvement in the sum of the emotions, and further this work can be extended so that the particular individual can measure the intensities of the particular emotion, like how much happy a person is, how much sad a person is. And one maybe use a concatenation layer at the merging process of these 2 models. So one can use the average weighted model or average weighted sum for that. Here are some of the references, and Thank you.
Thank you so much. I have one question about the rate recognition of emotions.
Okay. Actually, we have compared this emotion with the help of standard parameters like the confusion matrices and the F1 score and recall. So we have not used any our own custom parameters, like we have not created our own parameters. So we have generally used the simple the standard method for the comparisons with the existing works.
Okay, thank you.
Deep, how did you make the speech and
Yes, sir.
image compatible for fusion for CNN?
Yes, sir. So what the main issues was, sir, with the fusion, that for the concatenation layer, we have to give the same input shape for the concatenation layer. So actually we have you. So actually the input shapes are basically the 2 to 4 into cross into 2 to 4 into 3. So we have simply reduced it to the single bit, and we have oversampled the speech samples.
My question would be actually more appropriate if I would say that you are assuming that we are having low resolution images which would work with speech, because there is a very little difference between them. But wherever we are going to move to any image which is high resolution, then we would naturally need to add another step of converting it to a low res and then work with it. Isn't it?
Yes, sir. Yes, sir. So actually, sir, we have basically test with the FPRE only right now. So we may we extend it to the for high resolution because we have not considered the high resolution images.
Okay, I get it. Thank you. Thank you.
Thank you, sir. Thank you, everyone.
So we have come to the end of this session. I sincerely thank our authors and presenters for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of this conference. I hope to see you in the 9th version of this conference as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication would be live within 6 months. So kindly cooperate with the team of ICICT 2023. I also thank our session chair, Sachin Gupta and Malnika Innova for chairing the session. This is a token of appreciation from my side, sir. And ma'am, thank you so much for chairing the session.
Thank you.
I request all the participants to turn on their cameras for a quick snapshot, please.
Okay, I would like to thank you to everybody here about their great presentations and different point of views, because we see different topics and different opinions, and also we see that the research is going on, and this is one very nice solution of some problems. So I wish success in the future of all our colleagues who has possibility to participate in this great conference. Thank you.
Thank you. Thank you so much, everyone.
Thank you.
It was great to have you guys here. Stay safe. Take care. Bye.
Bye.
Thank you too.
Bye.
Bye.
Thank you.
Thank you.
Thank you, everyone.
Thank you.